Hello, my name is Dimitrio Martinez, and I'd like to talk to you about correlation, specifically about common applications or common uses of this type of statistical technique. Perhaps the most basic and common type of correlation used to measure and describe relationships among variables is the person-product moment correlation, or simply known as the Pearson-R correlation. This type of correlation, as other correlation types, measures the degree and the direction of linear relationships between two variables. But again, instead of focusing on the method in which correlations are computed, I'd like to discuss common ways in which correlations can be used. Four common applications or ways in which correlations statistical techniques are employed are for the purpose of prediction, to test or measure validity of a particular testing instrument, to determine reliability or the extent that a measurement procedure produces stable and consistent measurements, and also for the purpose of theory verification. Oftentimes, a researcher is interested in the degree of relationship or association between two variables or among more than two variables. Say, for instance, personality traits such as an individual's motivation or intelligence as measured by IQ score, and performance indicators such as test scores or GPA. One purpose of correlation, and perhaps the most widely used, is precisely to predict the outcome of such relationship or association between variables of interest. As you know, there are different types of correlation. In this scatter diagram to your right, you can see a positive correlation. As one variable increases, so does the other one. Take, for instance, college entrance exams, such as the SAT. SAT scores are often used to predict academic success, or more strictly speaking, a student's GPA. Here, in this other scatter plot, you can see that students with a high SAT score tend to achieve a high GPA as well. On the other hand, students who have difficulty with the SAT or who have a low SAT, they tend to achieve a lower GPA. That's generally the case during the first year of college, we should say. We can also have a negative correlation as shown in our next scatter diagram. As one variable increases, the other one in turn tends to decrease, as it tends to be the case with school absences, as shown in this other scatter plot. As students tend to miss classes, the more they miss classes, their exam scores tend to drop as well. So we have another correlation. In this case, this is a negative correlation, and it can be used to predict, in this case, an exam score based on the number of missed classes. Finally, we can also have a no correlation when the two variables of interest show no statistical relationship whatsoever, as it tends to be the case with the relationship between shoe size and IQ score. Generally, a prediction or regression equation is developed with the use of mathematical formulas, but as mentioned earlier, we won't get into the formula computation this time. Another common application of correlational studies is to test or measure validity of a particular testing instrument. For example, health and physical fitness practitioners have compared the relationship between indirect anthropometric body fat measurement devices by using a simple and inexpensive manual device or even an electronic device called a skinfold caliper. This is the manual, this is the electronic caliper, and they have compared the validity of such instruments to a more direct method of body fat estimate, or what's actually considered the gold standard for measuring body fat in an individual, such as performing an underwater weighing or using a dual energy X-ray absorptiometry to estimate percentage, again, of a person's body fat. Correlational research has shown that skin fold thickness in certain body areas using this device here actually correlates strongly to direct measures of overall fat, as shown in this scatter plot. In this way, the use of skinfold calipers technique can be considered a valid method for assessing body fat. In addition to predicting relationships in a systematic way and also evaluating the validity of measurement procedures, correlations can be used to determine reliability or the extent, again, that a particular measurement procedure, for instance, produces stable and consistent measurements or results. In other words, a reliable measurement procedure produces the same or nearly the same results when the same individual, and this is important, the same individuals have to be measured twice or more times under the same conditions. Correlations, again, can be used to assist researchers by precisely measuring reliability between two or more sets of measurements. Take, for instance, our previous example of body fat measurement using a skinfold caliper. By taking two different measurements for each individual, researchers can compute the correlation between the first and the second score and compare how similar or how dissimilar these scores are. A strong positive correlation between both measurements will suggest a good level of reliability. People who score high on the first measurement will tend to also score high on a subsequent test. On the other hand, a weak correlation, whether it is positive or negative, a weak correlation will show an inconsistent relationship between both sets of scores, and therefore it will show an unreliable measurement procedure between both scores. Finally, another practical application of correlational research methods is for theory verification. Researchers interested in verifying a well-tested explanation that is supported by evidence-based data may test or verify such theory through correlational research methods. Let's say that a researcher is attempting to verify or confirm the link or association between a certain risk factor for heart disease, such as smoking or physical inactivity or obesity, or each of these factors combined. He or she must be able to replicate the results of such widely accepted theory, and correlational studies can help them link the gap between their hypothesized variables of interest and this other widely accepted empirical evidence of such theory. As we have seen, four common applications or ways in which correlational statistical techniques can be used are: for the purpose of prediction, to test or measure validity of a particular testing instrument, to determine reliability, or the extent, once again, that a measurement procedure produces stable, consistent measurements, and for the purpose of theory verification. Thanks for watching.